In this video, I'm going to talk about making predictions. How do we make prediction? When linear correlation is significant, we use the regression line y equal to a plus bx. Plug in the x value to find the prediction value y. When the linear correlation is not significant, we simply use the mean of the y's. In other words, we use y bar. 8 pairs of data yield the regression equation y equal to 55.6 plus 2.8x with y bar of 71.5. What's the best predicted value for y when x is 5.5 if we assume the linear correlation is significant? Since the linear correlation coefficient is assumed to be significant, we use the equation of the regression line. We simply plug in 5.5 and find the prediction value. So in place of x, we put 5.5. We follow the order of operations, and y becomes 71. So the prediction value is 71. Ten pairs of data yield the regression equation y equal to 73.5 minus 4.5x with y bar of 58.5. What's the best predicted value for y when x is 4.5? This time we assume the linear correlation is not significant. Since the linear correlation is assumed to be not significant, we use y bar as the prediction value, regardless of the x value. So no calculation needed since y bar is given. So our prediction value is 58.5. Study time and midterm exam scores for random sample of 10 students is given in the table below. We're going to use TI command, linear regression t-test, to find CTST, p-value p, and linear correlation coefficient r. We store these values in L1 and L2. We press stat, tests, linear regression t-test, L1 for x-list, L2 for y-list, frequency of 1, and rho not equal to 0 with the regression equation blank. As displayed here. Now we're going to press calculate. So we have the CTS, we have the p-value, and more information. So the CTST is 9.626, p-value of 1.1 times 10 to the negative 5, and linear correlation coefficient R is 0.959. We can also find the equation of the regression line. A is approximately 46, B is approximately 5, and the equation of the regression line will be y is approximately 46 plus 5x. Now use the study time and the midterm exam scores of the last example of 10 randomly selected students. Determine whether the linear correlation is significant or not at alpha equal 2.05. Then make the prediction of the exam score for a study time of 7 hours. We set up HO and H1. HO, rho equal to 0, which implies linear correlation is not significant. H1, rho is not equal to 0. Linear correlation is significant. Since our p-value is less than or equal to alpha, then H1 is valid, which implies that the linear correlation is significant. Now, since the linear correlation is significant, we use the regression line for the prediction process. For x equal to 7, we plug in 7 for x. We follow order of operation, and our prediction value for exam score, if someone studies 7 hours, is 81. If we were to assume that the linear correlation coefficient is not significant, then the prediction value is y bar, which is summation of y over n, 782 divided by 10, 78.2 rounded to 78 as the prediction value. I hope this short video helps you understand how to make predictions, whether R is significant or not.